Okay, so in this video, we're going to look at solving for angles in a right angle triangle using our trig ratios. So we've got something like this here. Sine of theta is equal to 0.45. So in this case, we need to go backwards and find out what theta is. And just like when you're solving a regular equation, you have to use the inverse operation. So the inverse of sine is just called inverse sine. Okay, so it's really simple, and we would just write it like this. Okay, so the inverse of sine is written like this, sine with a little -1 on the top there. So if we want to solve for theta, and remember theta is just our angle, it's just the symbol we use to represent an angle, we would say that theta is equal to the inverse sine of 0.45. Okay, and then we can type that into our calculator, which is really simple. If you go back to where your trig functions are, you'll notice that under the sine button, there is an inverse sine button. So you would click that and then put in the value, so 0.45, and then Control Enter, and you'll get 26.7437. So rounded to the nearest degree, that means that theta is 27 degrees. So we would say we've got theta equals 27 degrees. Okay, we'll just try one more. Here we've got cos of theta is equal to 5/12. So the only difference here is that we're using cosine and that it's in fractional form, but it's the same steps. To solve for theta, we would do the inverse cos of 5/12. Okay, so we go to our calculator. Trig functions, inverse cos this time, and you can put it in as a fraction. So here's my fraction button, and I've got 5/12. Okay, Control Enter, and I get 65.3757, which rounded to the nearest degree is 65 degrees. So theta is equal to 65 degrees. Okay, so now we're ready to try an example. So here's the first one here. Find the value of theta correct to the nearest degree. So we're going to use the same steps that we did when we went to solve for a side length. So the first thing we should always do is label the sides that we're given with respect to the angle that we want to find. So 43 centimeters here, that's my hypotenuse because it's across from the right angle. And 16 centimeters is the adjacent side because it's beside the angle and in between the angle and the right angle. So I'm going to write out my word here, SOHCAHTOA. And I can see that because I've got the adjacent and the hypotenuse, the trig ratio I want to use is cosine. So let me write my ratio out. The cos of theta is equal to the adjacent over the hypotenuse. And then I'll just substitute the values that I know. So this time I want to find theta. So I'm going to rewrite that cos of theta is equal to the adjacent, which is 16, over the hypotenuse, which is 43. So to solve for theta, I need to use the inverse cos of 16 over 43. Okay, so putting that into my calculator, inverse cos of 16 over 43, Control Enter, and I get 68.1552, so rounded to the nearest degree, I would get theta is equal to 68 degrees. Okay, and that's it. We're going to do one more example, that is a word problem, and then you can try the problems on your own. Okay, so example 2. A helium-filled balloon is attached to the ground by a 24.5 meter string. A light breeze is blowing so that the base of the balloon is at a height of 22.6 meters above the ground. What is the smaller of the two angles to the nearest degree that the string makes with the ground? Now, when you're doing a word problem, first thing that you want to do is always draw a diagram if one isn't given. So we've got this balloon and it's attached by a string. Okay, now in the question we're told that the string is 24.5 meters long. So let's just label my diagram here. I've got a string that is 24.5 meters long. Okay, and it's saying that the base of the balloon, so the base of the balloon is here, is at a height of 22.6 meters above the ground. So if I just sort of drew this in here, that is 22.6 meters above the ground. Okay, and the height and the ground are going to make a right angle. So there's my right angle triangle. What's the smaller of the two angles that the string makes with the ground? So here's the string and the ground. You'll notice it makes two angles here. There's a bigger angle on this side, but we want the smaller angle. So this would be our theta. So we're trying to work out the angle the string is making with the ground. Okay, so now we've drawn our diagram and we just have a simple right angle triangle problem like we're used to. So first step is we're going to label our sides. Okay, so we've got the hypotenuse here. Okay, our longest side across from the right angle. And because we've got theta that we're trying to solve for, this side is the opposite side, so it's opposite theta. So the ratio we want to use, so I'll write in SOHCAHTOA for us. Okay, the ratio we want to use, we've got the opposite and the hypotenuse, so we're going to use the sine ratio. So we know that sine of theta is equal to the opposite over the hypotenuse. Fill in what we know. So we don't know theta yet, but we know the opposite is 22.6 and the hypotenuse is 24.5. Okay, so to work out theta, we need to do the inverse sine of 22.6 over 24.5. Sorry, that's looking a bit messy. 22.6 over 24.5. Okay, let's put that into the calculator. So trig functions, inverse sine. I'm going to put it in as a fraction. 22.6 over 24.5. Control Enter. And I get an answer of 67.2868. So rounded to the nearest degree, that is 67 degrees. So theta is equal to 67 degrees. And that's my final answer. Okay, so those are the examples for finding an angle. You can now go on to the questions from this chapter.